In this lesson, we're going to review the topic of quadrilaterals. Remember that a quadrilateral is a four-sided figure. You'll notice that I've already filled in a lot of these notes, so feel free to pause the video and make sure that you write down everything that I've written down here. Or you can just write it in as we go. So let's talk about the two different ways that we can represent the organization of different quadrilaterals. The first one being the family tree. So this is a family tree of the quadrilateral family. You can see that it's broken into three different sections. You can see that the first one is going to be indicated by our little arrow going over to the trapezoid family. And then the middle one is going to be going to the kite, and then the one on the side here is going to be going to the parallelogram. All of these figures are quadrilaterals. They're just different, they're in different sides of the family. So let's go ahead and let me give you a little tip on how to read these quadrilaterals and determine if they're always, sometimes, or never a different quadrilateral. What I mean by this is, if you look up at the top, I put a little, just a little tips on how to remember this. So anytime that you read up the chart, your answer is always going to be always. Let me show you what I mean. If I start over here with the rhombus and I say, okay, is the rhombus a parallelogram? A rhombus, a parallelogram. You're reading up the chart. Therefore, the answer is going to be always. A rhombus is always going to be a parallelogram. Another example of that would be, is an isosceles trapezoid a trapezoid? And your answer would be always. An isosceles trapezoid is always a trapezoid. Then you have the tip of reading down the chart. If you're reading down the chart, your answer is going to be sometimes. So let's go look at this one. A parallelogram, is it sometimes a rectangle? And the reason that it's sometimes a rectangle is because parallelograms don't have to be rectangles. They could also be rhombuses, couldn't they? So reading down the chart will give you the answer of sometimes. Here's another example. If I'm over here on the trapezoid side and I say, okay, is a trapezoid a right trapezoid? Well, it could be, but it could also be an isosceles trapezoid. So the answer is sometimes. And then the third tip here is reading across the chart. Reading across the chart means something like this. If I ask myself, is a trapezoid a rectangle? Notice how I went from this side of the chart all the way over to this side of the chart. Different sides of the chart. Your answer is always going to be never. They are not the same figure. Another example would be if I went from a parallelogram to a right trapezoid. Notice how I'm going across the chart. A parallelogram will never be a right trapezoid. They don't have the same characteristics. Now, we didn't really talk much about the kite. Unfortunately, the kite is not really talked about in 7th grade. You'll learn about that a little later on. Okay, so that's how you read the chart. You will not have this chart on your SOL, so I encourage you to study this chart and draw it out whenever you're taking your SOL. It will really help you answer some of the questions. All right, let's go ahead and answer some questions. Down here at the bottom, it says, the tree is helpful for always, sometimes, and never statements, like we just learned. Let's look at A. A square is blank a parallelogram because, well, a square is always a parallelogram. So let's go ahead and put always there. And the reason is, if we look at our Venn diagram, we have a square. Let's go put our pen on the square. And you see that the square is going up the chart to get to parallelogram. Therefore, it's an always statement. And another reason why is it has all the characteristics of a parallelogram. So that's how we know it's going to be always. Now, I know we didn't really talk about the kite, but let's go ahead and answer this question just because we know we can. A kite is what? A trapezoid. Because, well, a kite, it's never going to be. Because, look, we're reading across the chart. And the real reason why, characteristic-wise, is it doesn't have one set of parallel sides. And let's look at C here. A parallelogram is what? A rhombus. Because, well, a parallelogram is sometimes. Sometimes going to be a rhombus, and I think we talked about this one already, because sometimes a parallelogram has 4 equal sides, but not all the time. If it had 4 equal sides, it would be a square, or it'd be a rhombus. But it's not always going to look like that. It could be a rectangle. So hopefully that chart helps you read the parallelogram characteristics in. We're going to look at those characteristics in just a moment. But I did want to show you one more organizational tool for you that might be helpful, and this is called a Venn diagram. Now, a Venn diagram looks like this of the quadrilateral family tree. So you can see that the main square that's all the way around all the shapes is the quadrilateral. Notice that he's on the outside. So all of these inside are going to be representing different quadrilaterals. So that's a little tip here. If you read this little tip here that I give you at the bottom, that's how you read a Venn diagram. The shape has all the characteristics of the shapes it is within. So what I mean by that is, if you take a look at the parallelogram, you can see that the parallelogram is within the quadrilateral. It's not within the rectangle or the square or the kite. It's not in any of the other squares. It's only in the quadrilateral. Therefore, the parallelogram has all the characteristics of a quadrilateral. Another example would be, let's look at the isosceles trapezoid square. Notice that the isosceles trapezoid square is within the trapezoid square, which is also within the quadrilateral square. So anytime it's within, it is also holding all of the characteristics of the shapes that it's within. Hopefully that makes sense. So you can really look at the Venn diagram or a family tree, and whichever one works best for you is the one you should use. Let's go ahead and try to answer this question here using the Venn diagram. It says at the bottom here, so a rhombus is also a what? So if you look at the rhombus, you can ask yourself, well, the rhombus is within what other squares? You can see that the rhombus lies within the parallelogram square and the quadrilateral square. So I'm going to go ahead and circle parallelogram and quadrilateral. You might ask yourself, well, is it within the square? No, the square is actually within the rhombus. So you don't want to get those backwards. Okay, now that we've reviewed all of the different quadrilaterals and how to organize them, let's just take a quick review of all the different characteristics of the quadrilaterals. So let's just look at the first one here, and that is just the main quadrilateral. And we talked about this. A quadrilateral is just a figure, it's a closed figure that has 4 sides and angles. The next one we're going to talk about here is that one that we don't really discuss much in 7th grade, but I'm going to go ahead and put it here. This is a kite. And a kite, the kite's characteristics is, well, it has no sets of parallel sides, and it has 2 sets of adjacent congruent sides. So I'm going to go ahead and write that in. I have 2 pictures of 2 kites here. You can see that I have 2 sets of congruent sides here, and it's indicated by my little congruent markings. And none of the sides are parallel, so I don't have any parallel symbols on these 2 figures. Now let's move to the trapezoid. The unique characteristic of a trapezoid is that it has 1 set of parallel sides. That's it, just 1. So that kind of separates it from the other side of the family tree, because all of the other quadrilaterals, they all have, of course, besides the kite, but they all have 2 sets of parallel sides. So the only figure is the trapezoid that has 1 set. So you can see that I have 3 different pictures here, and you can see that these little symbols that I have written here are the symbol for parallel. You can see that all 3 of these trapezoids have parallel sides, just 1 set. All right, the next one is going to be the parallelogram. What's unique about a parallelogram is that it has 2 sets of parallel and congruent sides, just like we talked about. So that's the difference between the trapezoid and the parallelogram and the 2 sides of the family tree. You can see I have 2 examples here showing you this, that you have these opposite sides that are going to be parallel and congruent. What's unique about the parallelogram is that the angles are also going to be, opposite angles are also going to be congruent. You can see that in this picture here. Notice how these little arcs are representing that these 2 angles are congruent, and then the opposite angles are also congruent. Unless you have a rectangle. Now, remember, a rectangle is a type of parallelogram. So let's go ahead and move to the rectangle. A rectangle has 4 right angles, and it also has 2 sets of opposite sides congruent. And you can see that these two pictures are our rectangle, and you can see that our little symbol here is just our 90-degree angle, and you can see that all four angles add up to 90 degrees each. All right, our second to last quadrilateral is the rhombus, and what's unique about the rhombus is that it has four congruent sides. I like to think of the rhombus as the square on a slant. So what's unique about it is that all four sides are equal, and then the opposite angles are going to be congruent as well. And then we look at our square. We have four right angles, and then we have four congruent sides. So it's very similar to the rhombus. But again, a rhombus is kind of like a square on a tilt. So these are kind of summing up all of the characteristics of the quadrilaterals. And go ahead and try the questions at the bottom, and feel free to use your notes to help you.